Okay, hi, it's me again. Sorry, I got cut off. I didn't realize that the Screencast-O-Matic that I'm using only gives me a 15-minute window. So, all right, so here we are. At this point, you guys should have already checked this one out. And we have the 32 as the average rate of change, okay?
I got it.
My goodness, I cannot get this video filmed. You probably didn't know I paused. I just had the doorbell ring. Got neighbors selling stuff. And my kids are running around wild, so I'm sure I'll have to pause or you might hear some screaming some more here. Okay, so take a moment, please, and read what you see. All right, so we have a typical pool that holds 12,000 gallons of water. Now, I have a pond in the back, and it's just a koi pond. It's not huge, but with a little bit of hose for it to go up at least 3 inches, it takes a little over an hour. So it does take a long time to fill it up with a regular hose. So you can have these huge water trucks that come in and they pump water in, okay? So I'm going to give you this information right here. And what I would like you to do is I would like you to write the equation for this data. So if you could pause, please, and give them 3 or 4 minutes to work on this. Thank you. All right, so we're back. Now, recall from this that we need to, figure out the slope. But the problem is that these are not increment patterns that are going in the same amount. So if you recall what we were doing before is we were taking the lowest and highest of the points and we were calculating the rate of change from there. Okay? So we're going to take the rate of change. We're going to use the smallest point and the largest point. And what I'd like you to do is, if you were struggling doing that, is try to find the rate of change real quick with that. Go ahead. So Nick, when we set up the slope formula, we're going to subtract these two pieces, right? We're going to subtract those out. So Nick Handel, which 12,000 minus 6,000? Awesome, 6,000. And then we have 15 in the denominator. So next, what is 6,000 divided by 15? Beautiful. It's going to give us 400, or 400 over 1 is what I like to think about. So then that means that the rate of change, the water is increasing by 400 gallons per 1 minute. That's what this rate of change is indicating. 400 gallons of water is increasing per minute. So now we have to write our formula, right? So if the table had been in a pattern, we would have put an X right here, and we would have gotten a 400X here for the most part. So what do we think that the equation is? Is it y equals 400x? Raise your hand if you think it's y equals 400x. I wonder what happened to my little 4 over there. Okay. All right. So those of you with your hands up, you would be partially correct. But you have to remember that we're doing slope-intercept form, y equals mx plus b. And all the problems that you were doing with the animal ones, the b, the beginning, all started out with 0. But this one doesn't. Remember, it's starting half full. So it starts out with 6,000 gallons of water in it already, which means that we should have y equals 400x plus 6,000 this time, because we didn't start at 0. Okay? And if you had checked it, just the 400, if you come back up here, 2 times 400 is 800, not 6,800. So you have to add that 6,000 to it. And then I'm going to change the letters, right? Because we can use time, we can use T, which you guys can also use M for minutes if you want. Water, we can use W. But if you're going to use M for minutes, then use G for gallons, okay? So I'm going to rearrange that then. And if we write that equation out, we should get WT equals, W of T equals 400T plus 6,000. All right, so we've gone through all the problems that we need to. Now what you're going to be given is you're going to be given a practice problem. You can hear my kids in the back. You're going to be given a practice set of problems, and then the last 15 minutes of class, you're going to complete your assessment on slope and writing an equation, okay? So I hope this was helpful. You have a great weekend. I'll see you later. Bye-bye.